again, time to continue with our organic chemistry journey. Last time, alkanes. Altogether, not very exciting really, not much goes on with alkanes. Hopefully you've watched the alkane video and the mechanism, so you're familiar with the word mechanism for photochemical substitution using halogens. Bromine was often the example that you see. Often you see that, but it could just as well be others. Alkenes, whole different ballgame. C double bond C present in the, well, whichever alkene molecule you've got. Now at GCSE, ethene in particular was probably used as an example. Altogether more reactive, seen by the identification of, oh, we've got an unsaturated hydrocarbon by using bromine and it reacts with the ethene. It usually would have been in the test tube. You'd put the bromine in, you'd shake it and it would lose its colour. Still relevant. It's going to be part of what goes on in what we do here today. Much more reactive as a functional group. Now at GCSE you were limited to that addition reaction, which I hope it was called an addition reaction, and the other reaction would have been polymerisation. Now at A level those reactions are still relevant, but there's more. There's more reactions to know because alkenes do a whole load of reactions. They're fantastically good at doing a range of reactions. In fact, there are more reactions than A level has in it. There are loads more. So the actual set of reactions is quite restricted, and you need to know what's going on in a bit more detail. Firstly, you need to know the types of reactions, and there's a little bit of language to get on board with about the types of reactions. The number of reactions that you do for alkenes, you need to be able to go, that's the reagent, I know what that reagent does to an alkene, I will be able to apply that to the alkene I am given and write something suitable for the product. So you need to be able to apply what reagents do to whichever alkene you are given, because you're not going to be, it's not going to be ethene, well, it might be, but it's probably going to be some other alkene, because the beauty of organic chemistry is that the functional group, certainly at A level, reacts the same way, pretty much. I can think of one exception, but not in alkenes. Pretty much reacts the same way, regardless of the context with which it is within a molecule or the environment around it. So therefore, this knowledge here is the application knowledge for, I know what the reagents do, I can apply it to whichever molecule I'm given. And examples do like to throw you a new molecule and get you to say what would happen with certain reactions, of which alkene reactions could be an example. The last thing is mechanisms. Now if you watched and have understood and done the practice with the free radical mechanism that is the photochemical substitution of alkanes, that's a mechanism. There aren't that many mechanisms in A-level chemistry. I kind of think of it as 6. It depends on how you interpret what some of the mechanisms are, but it's kind of 6 basic ones. There's only one mechanism you need to fully understand and what it means in terms of how the product is generated for alkenes. So that's obviously important. That's going to be in its own video. It's already there if you can find it. But before you can do that, you need to know about the first two. So this video today is about these two here. And that one comes on its own video because it's really important. It's quite detailed. So I'm going to get ready for what we need to do next, and I'll see you in a moment. So I know I said the video wasn't about mechanisms. Just want to say something about the difference between the reaction, which means that your mechanism looks different. In free radical substitution mechanisms, like with the alkanes and the photochemical, you had these half-headed arrows because these represent one electron moving in a particular way. When you talk about mechanisms usually, and the two types of mechanisms you have, apart from this one special example, because it is quite special, it's the only time it occurs, is what's called electrophilic and nucleophilic. Now I'm not going to go into that because that's all part of another video, but the two things that you're going to be talking about with mechanisms are going to be electrophilic and nucleophilic. Electrophilic is something seeking electrons, nucleophilic is something seeking positive charge. So seeking negative, seeking positive. And you're going to do that with a pair of electrons, so this makes the whole reaction set very different in the way it works. And a pair of electrons has a double-headed arrow to represent the two electrons. So these two words are going to be your mechanisms are going to come out the same. So we're going to focus on the type of reaction for alkenes, which is electrophilic addition. So electrophilic is one of those two mechanistic words. Addition, we'll just explain that in a second. You might want to know what that is. So something that is called an electrophile, which means it will do electrophilic mechanisms, is electron deficient. That makes it either positive or just electron deficient and in need of electrons. That usually means it's got 6 electrons. Free radicals have an unpaired electron and have usually, although not always, because of hydrogen, but they have 7 electrons, which is the one unpaired electron on top of this. And so they use 6 electron species most of the time, because there are a few exceptions to that where you've got hydrogen, for instance. And it seeks out electrons. So you are looking for a substance that's going to seek out electrons. Addition is taking 2 substances, I say substances because it could be a compound, could be an ion, and they combine and they produce only a single product. So you start with 2 different particles and end up with 1 particle as a product. There isn't a 1 in 1 out thing, which is called substitution, which you would have had here. So we are going to be focusing on electrophilic addition. Different video for the mechanism where we start to look at all the ins and outs of the reaction. What we're going to focus on for the rest of this video is the types of reactions that you need to know. Now there's a bit of an issue with different exam boards when we come to that. Not all exam boards have every single reaction in. It's one of the ways that exam boards make themselves slightly different is a lot of the chemistry is common and there's occasional things that are in for one board and out for another board and a different thing in for that board. And it's kind of almost the same number of reactions, it's just there's a central core and a few extras. So we're going to go through all the possibilities that you will have, and I'll see you when I'm ready for that. So this is kind of the take lots of notes section, because we're going to go through these 5 electrophilic additions. There are a couple of other reactions you need to know about that are not electrophilic additions. We'll do those after we've done the electrophilic additions. So there are 4, and then there's this. I'll come to that in a second. So they're all additions. So this is the addition of bromine. It doesn't have to be bromine because I've put X2 here. It does the same with chlorine, Cl2, and iodine, I2, but most questions go with bromine. Bromine is kind of like your fallback position when it comes to choose a halogen for organic chemistry. So there are also hydrogen halide reactions, HBr, fallback position, but also HCl and HI. Steam, but steam water, H2O, does not react directly with alkenes. It needs a catalyst. That catalyst is, well, you can have aluminium oxide as a catalyst, and some examples do have that, but most examples in the UK have phosphoric acid as the catalyst. So H3PO4 is the catalyst. I haven't written the word catalyst next to it. That is the catalyst. And not in every exam board is potassium manganate. Potassium manganate has to be acidified in order to do its oxidations, and the H plus is the catalyst for that reaction. So there are 4 reactions in the electrophilic addition set. Now this is number 5. Now this is there only because a couple of times in my time as a chemistry teacher, it's been a while, I realise I've been doing it a while, there have been questions about a chemical called cyanogen. Now cyanogen has this structure. It's a particularly unpleasant chemical in terms of coming into contact with it, but you're not going to come into contact with it because you're not going to do that. But it doesn't mean that you don't see it once in a while in questions. So it goes like, it's written like that in reactions. And that's equivalent to reacting like bromine. And I've seen it a couple of times in questions, so I will mention that a little later. So we're going to take each one of these in turn in the following parts of the video, just to get you to understand what will happen to an alkene in each of these places. So I'll see you in a moment. So going through them in order, bromine first, bromine being number 1. I should have put a 1 next to it, there we go. Bromine, alkene reacts with the bromine to produce a dibromo, sorry, badly written, dibromoalkane, so it shouldn't say alkene. That's not, now these arrows are not mechanistic arrows, they're just the reactant to product arrows. A dibromoalkane. You need to be able to say more than that. You need to be able to go, oh, there's my alkene, I'm adding bromine, and it will locate the bromines at either end of where the double bond used to be. So there it is there. So I want you to have a quick pause me, write down what you think the product will be, and I'll come back with the product in just a moment. See you in a second. So hopefully you drew that. Reactions with bromine, locate where the double bond was, bromine at either end, done. So cyclohexene, that'll be 1, 2, 1,2 dibromocyclohexane, dot your I. That is 1, 2 dibromopropane. So yes, you do need to be able to name them. Yes, you do need to be able to follow the rules from the naming. Oh, that was in an earlier video. If you haven't got that and you're still not clear about that, go back and look at the video again. That's why they're still there. Right, so number 1, bromine. A couple of examples. There is also attached to this video some follow-up questions where you can practice what goes on. But I'll move on to reaction number 2. See you in a moment. So, second reaction, HBr. Remember, it could be HCl or HI. Not HF. HF doesn't do it. So, basic reaction, alkene to halogenoalkane. 1 halogen this time, not a dihalogenolalkane. I realise some exam boards do call halogenoalkanes haloalkanes. I can't get around that. I mean, the word is slightly different. It's what it is. The product is still the same chemical. So, done with the simplest alkene, here's what happens. HBr, hydrogen goes onto one end of where the double bond was and the bromine goes onto the other end. So it still puts them on either end of the location of where the double bond was. So I want you to have a little think. This is a big thing as well. Here's propene. There are 2 organic products. See if you can unravel where I'm going to go with what happens here. I'll see you after you pause me and had a go at those. So have you had a go? Look. 2 products. Did you get that you could put the bromine on at one end or the other end of the double bond, because that's the choice. Now you need to know more than that. You need to know, firstly, that those are the 2 possibilities. So you have the bromine going on in the centre carbon there, or on the end carbon, terminal carbon. But you need to know more than that. Now, the more than that information part comes in the mechanism. So the mechanism tells you how to do what I'm just about to tell you. This and that would be called major and minor products. So this is the major product, that's the minor product. Now the mechanism is going to explain the reason why. That's a different video, like I said. Major meaning you get more of it and you get less of this one. And there's a mechanism reason why that happens, and you need to understand that. It's called Markovnikov and anti-Markovnikov products. But that's all in the other video. So, you need to be aware of this. Now this is symmetrical. So if the double bond is symmetrical, you get one product. So if the double bond is in a symmetrical position, so that is a symmetrical double bond, you'll get one position. That is asymmetrical, non-symmetrical. So symmetrical, you'll get one product, unless the molecule perhaps is really complicated. But for most A-level questions, it will be fairly straightforward. Well, I suppose if it's a more complicated product, it won't be symmetrical, so it'll still fit with this. But if it's asymmetrical, like here the double bond is on the end, you will end up with two products where you can put the bromine here, you put the bromine here. This one only has one product, because if you put the bromine there, the other one where you put it there is exactly the same product. So you only get one. That's it until you do the mechanism video another time. I'm going to move on to reaction number 3 in just a moment. So here we go with the third reaction. Steam, literally meaning you've got to have not just hot water but vapour. Catalyst, as I've said, could be aluminium oxide, but most of the time it's phosphoric acid in A-level courses. So you add this, I've used propene there, we get two products. It's that same issue as with HBr. It's where do you put it? You put the whole thing on, with the OH in this case, does it go on the centre or does it go on the end one? Major, minor, just like before. So I want you to have a go with cyclohexene again. What do you think will happen? What will be put in over here? I'm going to get you to pause the video. And then, now you've unpaused me, what do we get? As I said, it's all about the functional group and you in the context of the molecule. And you put the OH on. Because this is a symmetrical, there is only a single product. Right, we're going to go on to the fourth one, and then I'll see you in a moment. So, number 4, acidified manganate 7, calcium manganate 7. You produce a diol. So this is ethane 1,2 diol, because I started with ethene. Now, if we started with butanene, there, what would we get? Pause. And now if you unpause me, ideally you will be aware that you will just diol across the two positions, or the two ends rather, of the double bond. So then, now with all of these reactions, if there were two double bonds, you would, provided there was a complete excess of whichever reagents you're reacting it with, it will react at both double bond sites. So with something like HBr, you will get 4 possibilities, because there were 2 possibilities on each double bond. So you do have to think how it's going to go. Now I'm going to return with the cyanogen problem. It's not a massive problem, as you'll see. I'll see you in a moment. So the issue with cyanogen is the only issue with it is not how it reacts, but it just throws people because it was thrown at people in the context of what's called unseen information. It reacts just like a halogen because it's called a pseudo-halogen because of the way it reacts with things. So it would add where both ends of the double bond, and it puts a CN where the double bond was. So what do you think would happen here? It's not hard to predict. I'm not even going to ask you to pause the video. I'm just going to say the carbon skeleton remains intact in all of these reactions. And so you have that there. I drew before, when we're talking about it, it has a triple bond between the carbon and the nitrogen. Why are things like this important? Because they grow extra carbons onto the carbon skeleton. So this has gone from 6 to 8 carbons. And you can then react this group in other ways. That's a different part of the chemistry course, but you would know that once you've finished. And so there we go. Now there are some other reactions that you need to know about as well that aren't 1, 2, 3, 4, 5 have been electrophilic addition. There's a couple of others. Going to do those very quickly, and I'll see you in a moment for them. Okay, last two reactions, not electrophilic addition. This one here, catalytic hydrogenation. Quite simply, take an alkene, hydrogen, appropriate catalyst, most textbooks it's nickel, technically it could be some other things as well. Temperature varies depending on which book you're looking at. I've gone for 160, which is a number of textbooks. Turns it into, there were 5 carbons, it's 5 carbons again, but it's now just an alkane. Now you might think, what's the point of that? Alkanes are useless. Yeah, I agree. But what you do with this reaction, this is the reaction that turns plant oils into margarine. So it has an everyday thing. Not that you do it yourself, obviously, it's done in a factory. Last thing, addition polymerisation. Many possible examples of alkenes. Catalyst, number of choices of catalyst depending on what you want to do. And there. All the details of that I'm going to put in another video because this just makes this video is getting too big. So this is all the stuff about polymers will appear in another video at some point. So there's the reactions. Now there are some follow-up questions where you get to, well, I guess you could say practice, because practice is what we need to do in order to apply these. So I'm not going to go through any more examples. I'm just going to leave you to go through the follow-up questions that are attached to the video and see how you get on. Obviously the answers will be there and you can test your understanding. Obviously this was about making notes up to this point. If you haven't made notes, why were you watching without making notes? Oh, stop me, start me, make me to notes. And then, well, do your practice and I'll see you for the video that comes after this. Bye-bye. Thank you for watching.